students, welcome to chemistry class. In today's class, we are going to learn an important reaction of alkene. As you know, alkenes are unsaturated hydrocarbons. Unsaturated hydrocarbons are the one which has at least one carbon to carbon double bond in its structure. So when we take alkenes, alkenes are having a general formula of CnH2n, which indicates that it is an unsaturated hydrocarbon. These alkenes, they undergo certain characteristic reactions. Let me take one example of alkene. All of you know this. We have the first member of alkene is ethene. Isn't it? When we look at the structure of ethene, we have carbon to carbon double bond here, and this double bond is nothing but is pi bond. So due to the presence of loosely held pi electrons, it is somewhat electron rich, so it will always show a characteristic electrophilic addition reaction. So one among the addition reaction is addition of hydrogen halides. So let us study about addition of hydrogen halides to the alkenes. Hydrogen halides. What are hydrogen halides? They have a general formula of HX. Here X can be either chloro, bromo or iodo. Based on whether it is HCl or HBr or HI, there will be difference in the reactivity. So as we know with the previous knowledge, the reactivity will increase from HCl to HBr, and HI will be most reactive, which can be explained with the help of bond dissociation energy. And coming to alkenes, alkenes are broadly classified into two types. One are symmetrical alkenes, another one is unsymmetrical alkene. So first let us consider here addition to symmetrical alkene. So addition of HBr I will consider for learning purpose to symmetrical alkene. Symmetrical alkene. What is the meaning of symmetrical alkene? We should have similar groups on either side of double bond. Or if I consider carbon to carbon double bond, these both the carbons should be having the similar groups on either side. So this is the simplest example we have for symmetrical alkene. When this ethene reacts with the HBr, we are going to get the product, that is bromoethane, CH3 CH2 Br. So this can be easily understood. We have HBr here. So this looks like addition of hydrogen to one carbon and bromine to another carbon. So we end up with having bromoethane as only one product. Similarly, if I take another symmetrical alkene, that is, we have 2-butene here. Let us take 2-butene. This is nothing but 2-butene. 2-butene upon reaction with HBr forms 2-bromobutane. 2-bromobutane. Yes. When we try to understand the mechanism of this reaction, before that let me tell you one point. Now here also I will consider the addition of hydrogen to one carbon and Br to another carbon. So if we take the addition of hydrogen to this carbon or this carbon, it is going to be the same. If the Br is added to this or to this carbon, we call it as 2-bromobutane itself. Only one product is possible. That is the nature of what? That is the nature of the symmetrical alkene we have. So the name of this one is 2-bromobutane. Yeah, it becomes very important in organic chemistry that we understand the mechanism of reaction. So in brief, let me give you the mechanism of this particular reaction which help us to further develop the concepts. Okay. So let us understand the mechanism, how this addition of hydrogen halide takes place for an alkene. Once we understand the mechanism for symmetrical alkene, the same thing we can apply for unsymmetrical alkene. So in the first step, in the presence of alkene, I will consider the reaction of ethene with HBr giving ethyl bromide or bromoethane. So in the first step, in the presence of this alkene, HBr undergoes ionization. We know hydrogen to bromine, the bond is polar because bromine is electronegative, hydrogen is electropositive. So this undergoes ionization to form H plus and Br minus. In the second step, this is an electrophile here, right? H plus is what? Electrophile because it is electron deficient, and Br minus here it is nucleophile because it is electron rich. Second step, we told alkenes are electron rich. So it interacts with the electrophilic part which is obtained from the HBr ionization, okay, forms carbonium ion or carbocation. Right? Hydrogen. So we can show the reaction here. Double bond will take up the H plus, forming one of the carbon you can consider here. So H will attach to this carbon, forming a carbon with a positive charge. Why positive charge comes? You know from the previous knowledge, because carbon has 4 valency. Here the valency is not satisfied. So this is a carbocation, or we call it as carbonium ion. Okay. In the third step, this is electron deficient. We have in the reaction mixture electron rich species, that is the nucleophile. So that nucleophile attacks the electron deficient center and forms the corresponding product here. Br attacks the electron deficient center, forms the product what is expected previously, that is bromoethane. Correct? So this is the mechanism of reaction. Similar mechanism you can work out for the rest of the examples. Okay. So as the attacking species is electrophile here for the alkene, we usually call this reaction as a electrophilic addition reaction. Yes. Now let us take the next example here. Next set. Addition of HBr to unsymmetrical alkene. Unsymmetrical alkene. What is the meaning of unsymmetrical alkene? There won't be similar groups on either side of doubly bonded carbon. The simplest one we have here, propene. CH double bond CH2. This is called propene, the second member of alkene. When propene is reacted with HBr, we end up with 2 products, not one product like previous case. One is CH3CHBr, that is 2-bromopropane, and another product is 1-bromopropane, CH2Br. So this is called 2-bromopropane and this is 1-bromopropane. With symmetrical alkenes, we got only one product. But in the case of unsymmetrical alkenes, we are getting 2 products. We know whenever we have more than one product, definitely one of the product will appear as a major yield and the other product will be in the minor quantity. So upon observation with similar unsymmetrical alkenes, here I can write 2-bromopropane is the major product and 1-bromopropane is a minor product. With only one reaction, nothing can be concluded. We have to study some more reactions to conclude it. So if I take some more examples here, okay, second example I'll consider. You take this one as the first example. Second example I'll take. Let us take but-1-ene or 1-butene. Okay, this is called 1-butene. When it reacts with HBr, again we get two products. One of the product is 2-bromobutane, 2-bromobutane, and another product is 1-bromobutane, 1-bromobutane. Now this product appeared as major and this is again minor. Okay. Let me take one more example here. Then let us conclude what is special with this kind of alkenes. Let us take CH3, CCH3. Double bond, we have CH2 here. Nothing but it is a propene only with 2-methyl. We have, this is nothing but 2-methyl propene. Yes, on reaction with HBr, we get CH3, CCH3, Br attaches to this carbon, hydrogen attaches to the terminal carbon. So we get 2-bromo, 2-methyl propane. Okay, as the name is different, I am writing it. Other cases you can name it. And maybe there is very small amount of, we get 1-bromo, 2-methyl propane. So that means this is a major and this is a minor quantity. After observation with a lot of such examples, with a lot of such unsymmetrical alkenes, Russian chemist called Markovnikov could able to generalize a rule which is known as Markovnikov's rule. According to the rule, what is the observation? Let us quickly take the observation. Look at this unsymmetrical alkene. Just concentrate on this doubly bonded carbon. This carbon has one hydrogen. This carbon has two hydrogens. Now, the bromine has attached to the carbon with one hydrogen appeared as a major. Correct? Look at this alkene. Again, this carbon has one hydrogen. This carbon has two hydrogens. We have again the bromine is attached to the carbon with one hydrogen appeared as major. Here this carbon and this carbon has no hydrogen, this has two hydrogens. Carbon attached with the bromine appeared as a major product. So upon observation, Markovnikov stated that during the addition of hydrogen halides, the major product is the one which the negative part of the addendum. Which is the negative part here? Negative part is Br minus. Negative part of the addendum. Addendum is nothing but one which gets added. Negative part of the addendum adds to the carbon with lesser number of hydrogen. This is widely known as what? Or it is very like important rule known as Markovnikov rule. Okay, Markovnikov rule. Later, they try to understand why this is a generalized rule upon observation. But we need to understand, being a chemistry person, why it is major and the other product appears as minor. Let us quickly recall the mechanism. In one step, we will understand that. Let us quickly recall the mechanism. We will have propene here, and in presence of HBr, I will not write three steps now. In the single step, I am going to show you. Alkene, in the presence of alkene, HBr undergoes ionization. It will take H plus and Br minus will be kicked off. Later it will come. So it is going to generate. Now you see, if I write this is the one way. I will write the path A here so that I can understand here the hydrogen is attached, and path B I am going to represent by this. Okay, here we will take the path B. Now in the first case, let us have the intermediate CH3, CH, CH2. That means the hydrogen will attach to the carbon here, CH3. Okay, so this carbon becomes electron deficient. In the path B, hydrogen will attach to this carbon, CH3, CH2 and CH2 with a carbocation. So this was the intermediate we obtained in the second step by the attack of H plus to the alkene. So here when we see this intermediate, which is the intermediate? This is known as a carbocation or carbonium ion. What is the nature of this carbon? This is in turn attached to the two methyl groups or the two carbons here. This is called secondary carbocation, right? Secondary carbocation. And this is attached to only one carbon, which is known as primary carbocation. Now, we know by the previous knowledge, secondary carbocation is stable, more stable. Okay, more comparative statement, more stable than the primary carbocation. Hence, by the next Br minus attack, we get 2-bromo-propane as the major product and 1-bromo-propane as a minor product. Hope you understood this. This is purely based on the knowledge of stability of carbocation, where we can apply the concept of chemistry. Why secondary carbocations are more stable, which you have understood with inductive effect as well as by hyperconjugation effect. Okay. Yes, the same way you can apply it to the rest of the two examples. You can understand the nature of a carbocation formed as an intermediate so that you can decide which is the major product. Or all these examples what I have given you, they are just based on the Markovnikov rule, because I have the doubly bonded carbon which has a difference in hydrogen. So I can straight away depend on Markovnikov's rule. Negative part adds to the carbon with lesser number of hydrogen. Now the challenge starts here. Okay, let us see what is the challenge for us, where the chemistry concept exactly plays its role, and that's what you study in NEET. Okay, let me take the fourth example here. C6H5CH2, we have CH double bond CH2. Okay, or before that I will take one more example here. CH double bond CH, we have CH3. Okay, this is nothing but C6H5 is a phenyl we are having. We can name it as 1-phenyl propene. Okay, let us react this one with HBr. So as we have stated previously, the negative part, which is the negative part, Br minus and H is plus, adds to the carbon one which has lesser number of hydrogen. Now look at the carbons here. Both the carbons are having same number of hydrogen. Now whom to give the negative part? Your Markovnikov rule won't help. You can't apply straight away the Markovnikov rule, isn't it? Look at the products. I will give you the products now. The product is C6H5, CH, Br, CH2, CH3. This is the major product. And another product will be minor, very, very less quantity you will find, CH, Br, CH3. Okay, so this is the major product and the other one is minor product. Right? So your Markovnikov rule didn't help you here, but what is the knowledge required? Again, the knowledge of carbocation and its stability is required. So to understand that, you should be strengthened with how to decide the stability of carbocations. Okay. Now let me take one more example here. Let us take CH3, CCH3, CH3, CH double bond CH2. Right? Let us consider the reaction again with HBr. Yes, try to apply the Markovnikov rule. We are very happy. These carbons are differing in the number of hydrogens. So you will be thinking that you can directly apply the Markovnikov rule. Negative and positive. Negative part adds to the carbon with lesser number of hydrogen. I think you are all guessing here. This could be the product CH3, CH, Br and CH3. But this product is appearing as a minor product. Minor product, surprisingly. Then which is a major product if you ask me? What is the major product? CH3, CCH3, Br attaches to this and CH3 will be migrated here and CH3 here. So this is the major product. See the difference. Which is unexpected product is going to form there. Isn't it? What is the product is this? 2-bromo 2,3 dimethyl butane. Expected was 2-bromo 3,3 dimethyl butane. But we are getting unexpected product. It is not according to Markovnikov rule. What made this as a major product? For that you need to again understand the carbocation intermediate, its stability, and there is you can see the methyl group here is migrated to the adjacent carbon, won't it? Migrated to adjacent carbon. What made this methyl group to migrate to the adjacent carbon? What is the driving force behind it? These things you are going to learn in detail for cracking NEET. Yes. Also, I will end up with one more example, and this example also I am leaving it to your thinking, okay, where you should really show the interest to learn the chemistry concepts. Sixth example what I am considering here, look at this. We have CH3, CH, CH double bond, CH2. Similar example, but I have a hydrogen instead of methyl, nothing but 3-methyl butene. Upon reaction with HBr, see again, look at the Markovnikov addition. Carbon has one hydrogen, so you are expecting here CH3, CH, CH3, CH, Br and CH3 as a major product according to Markovnikov rule. But this appear as again minor product. What is the major product then? Major product is this. Look at the major product. Br, CH2, CH3. Okay, this is the major product. By looking at the major product, you might have now thinking the hydrogen has migrated from this carbon to this carbon, isn't it? Hydrogen migrated to this carbon. So that the Br came here. Why hydrogen migrates? Why not methyl migrates? Previous case, methyl has migrated. Now hydride or hydrogen, but actually it is hydride is migrating, not the methyl group. Why it is so? Okay. To learn that, you need to really work on the intermediate. Who is the intermediate? I'll end my session by saying the intermediate for this reaction is carbocation. So about this carbocation intermediate and its stability, you need to have a very good or a thorough conceptual understanding. So with this, I'm going to stop the today's session. Thank you so much.